So basically, let me go and start a new project again from here, from my template project, same as before. Okay, there, and now I can actually to B. There. Design 02B, and also here again. Okay. So basically, when you have a source, for example, that button or some timer or whatever the interrupt source would be, first of all, you go and do some magic in case of button to get this one actually to be able to do interrupt on both edges. That's fine. Click. It does not generate any interrupts yet. You need to hook a component called interrupt service into it. So there is that system, I think. Interrupt. Okay, there we go. So we actually include an interrupt here. So this actually, the button now makes the interrupt request, but it doesn't go anywhere unless you also hook an interrupt service routine into it. So basically this will give you the hook to your own code. So then you just need to connect this point to interrupt service routine 1. And you just, I think you just double click, oops, not double click. How do you connect that one? Oh yeah, with a wire. So their wire tool on top design, click, clack. Now there is the interrupt service available for pin changing value. Okay, and now when I do generate application, it actually gives me some more source files, and especially one file. It gives you the module ISR1 code. And well, there's the header, but more importantly, .c. So here is the interrupt service code, which basically somewhere in here is a place, function definition, start, ex, no, stop. There. That's the place you put your own code, what happens during this interrupt. It says place your interrupt code here between start and end. Why is exactly there? If you put your code anywhere else and click generate application, that code will be destroyed. So basically, when you click the generate application, these code segments which are between start and end will remain the same. And in here, you could have, for example, some of the local variables defined, and basically, let's see, int 8 value equals, you could read the current button read, what is to read? Something. But anyways, so I don't remember it anymore. But anyways, so you basically put whatever you want to do here, you would put the code here. In this case, I would put here code first to read the state of the pin that also clears the interrupt request when you read that register, and then do whatever you need to do. Yeah, so that's how you do it. Code goes here. Okay, and that's not quite enough. After you have done a modification of the ISR.C, you need to also, in here, you need to say ISR1 start. Start. There we go. Yes. You need to start the routine. So basically this command goes and initializes the interrupts. So after that, that interrupt service code is active. So this is the simplest way of making the interrupt. So fundamentally it was that you'll first go to that, whatever your interrupt source is, make sure that it basically generates interrupt request signal. So this is internal signal. Then you basically add an interrupt, hook these together, then find the code for that one. Well, after, of course, clicking, not that one, clicking the generate application, you go and find that code for this component, and there basically go to the place where it says there, place your interrupt code here. Okay, easy. That's one way of doing the interrupt, and that's the simplest way. There's also the second simplest way available, but I think it's better to learn first this way and then maybe tomorrow try the other way, since you can also define or write your own code, since this one here, it's macro, which basically registers this code segment as interrupt service routine for this interrupt. You can use that same macro outside and then basically define that code as your interrupt service routine. Okay, but use the simplest way first. Yeah, whatever. Whatever. There we go. So that's how the interrupts work in this the system. So basically, for the exercise, you need to well, there's the UART, for example, but anyways, you need basically the timer. Where is the analog digital communication, digital PWM timer, where's a function, utility, search for PWM. There, functions, the PWM. You need the PWM block. What else you need? This is all in instructions. Actually, you need also a clock for that one. Clock signal. Clock signal to time this PWM module or component, and basically you can actually, for this clock, you can actually put any value here. So isn't that nice? On most of the these microcontrollers, you need to figure out the divider and that kind of things from the system clock or some other separate clock you can. But in this tool, it basically it's just a clock named a component where you practically just put here whatever frequency you want, and basically this component will be component will then decide itself how to make that one. There's some magic happening, of course, here. So basically, it has a couple of different internal oscillators, and of course it needs the frequency dividers after that one, but that's automatically made. So you don't need to worry about anything else than what is the desired output clock. Nice. For example, if I want to have a 10 kilohertz clock, that's how easy it is. Oh, there you go. Then I have a 10 kilohertz clock, which can be used, for example, to time my do timing for the there we go. Now it's connected. This component component is now a source for the PWM components at 10 kilohertz rate. But you can use your own numbers as long as you get this 20 milliseconds full period, and you can adjust this by this pulse width for the PWM. Okay, something like that. Basically, I let you to explore yourself how to configure the PWM module. You can choose either 6-bit or 8-bit or 16-bit PWM module, I think. Yeah. 8 or 16-bit resolution. Well, 16-bit is usually quite universal, so you can do lots of stuff. If you go to 8-bit resolution, then you basically think of this: you have 20 millisecond long pulse, and you have just about 10% in use. To get this one smooth, you cannot use the 8-bit. It doesn't have enough of resolution to put any ticks in between of these values. So 16-bit, but the rest of the parameters you decide yourself. Ooh, I got pretty close. Interesting. Very interesting. Resolution 16-bit, 2 outputs. Maybe just one output. One output. fixed function or would it be, yeah, okay. Period, so that's the full period and so on and so on. So basically, yeah, you can configure this one, and actually it looks like when I have the clock rate already given to this one, it also calculates the full period at the same time. That's nice, is it? Yes. Yeah, good. Yeah, now I have given you enough of hints. You can start working on the exercise, but I then first recommend you to take the lunch break now. Okay, so lunch break and come here within 1 hour, I think, say 1:30 at latest. If I'm not here, just start working on the exercise. Since more or less I have given you enough of information, the rest of that one is for you, so you can explore yourself. I'm here to help you for the rest of the day, and at the end of the day, I would like to see some movement on these servos. Good. Any questions? If not, then yeah, class recess.